Zika virus, ZIKV, infection remains a serious health threat due to its close association with congenital Zika syndrome, CZS, which includes microcephaly and other severe birth defects. As no vaccines are available for human use, continuous effort is needed to develop effective and safe vaccines to prevent Zika infection. In this study, we constructed 3 recombinant proteins comprising, respectively, residues 296 to 406, E296 406, 298 to 409, E298 409, and 301 to 404, E301 404, of ZIKV envelope, E, protein domain 3, EDIII, fused with a C-terminal Fc of human Ig. Our results demonstrated that E298-409 induced the highest titer of neutralizing antibodies against infection with 9 ZIKV strains isolated from different hosts, countries, and time periods, and it maintained long-term anti-ZIKV immunogenicity to induce neutralizing antibodies. Pups born to mice immunized with E298-409 were fully protected against lethal challenge with 2 epidemic human ZIKV strains, 2015/Honduras, R103451, and 2015/Colombia, Flor. Passive transfer of anti-E298-409 mouse seroprotected pups born to naive mice, as well as type I interferon receptor deficient adult A129 mice, from lethal challenge with human ZIKV strains R103451 and Flor, and this protection was positively correlated with neutralizing antibodies. These data suggest that the critical neutralizing fragment, that is, a fragment that can induce highly potent neutralizing antibodies against divergent ZIKV strains, of ZIKV EDIII is a good candidate for development as an effective and safe ZIKV subunit vaccine to protect pregnant mothers and their fetuses against ZIKV infection. The E298-409 specific antibodies can be used for passive immunization to prevent ZIKV infection in newborns or immunocompromised adults. Introduction. Zika virus, ZIKV, is an emerging viral pathogen associated with severe neurological diseases, including Guillain-Barré syndrome, GBS1-2 and congenital Zika syndrome, CZS, which includes microcephaly, brain abnormalities, and other severe birth defects 3, 4, 5, 6, 7. Increasing numbers of women have been infected with Zika during pregnancy and have given birth to newborns with congenital defects 7, 8, 9, 10, leading to serious consequences. A variety of Zika vaccines, such as those based on inactivated or live-attenuated viruses, viral vectors, DNA, RNA, and viral proteins 11, 12, 13, 14, 15, 16, 17, have been developed against Zika infection in experimental animal models, and several have progressed to clinical trials 18, 19, 20. To date, however, no vaccines are available for human use, a situation calling for a continuous effort to develop effective and safe vaccines against Zika infection. Zika belongs to the same Flaviviridae family as dengue virus, DENV, West Nile virus, WNV, Japanese encephalitis virus, JEV, yellow fever virus, YFV, and tick-borne encephalitic virus, TBEV21,22. The full-length genome of ZIKV encodes structural proteins, such as capsid, C, membrane, M, or precursor membrane, PRM, and envelope, E, in addition to non-structural proteins, NS1, NS2A, NS2B, NS3, NS4A, NS4B, and NS521,22, among which E protein is the major protein for inducing neutralizing antibodies against Zika infection 23,24 and, thus, a main target for developing Zika vaccines. ZIKV protein consists of domain I, DI, domain 2, DII, domain 3, DIII, a stalk region, and a transmembrane domain, supplementary figure S1825. A number of ZIKV-based vaccines were developed targeting PRME or full-length E11, 14, 16, 26, whereas a few have attempted to target fragments of ZIKV protein domains, particularly EDIII, to identify important regions in the E protein for developing more effective and safer ZIKV vaccines. 27. Although ZIKV protein is a key target for developing ZIKV vaccines, studies have found that antibodies targeting ZIKV-2 are generally cross-reactive and poorly neutralizing, potently enhancing ZIKV and DENV infection, whereas those targeting ZIKV-EDIII have the most potent neutralizing activity against ZIKV infection. 28. In addition, antibodies targeting DENV or WNVE proteins, including the fusion loop region, may bind and cross-react with ZIKV-2 region, but they do not neutralize ZIKV infectivity, thus promoting antibody-dependent enhancement. EDIII 29, 30, 31. In this study, we constructed 3 recombinant proteins comprising ZIKV-EDIII fragments of different lengths and found that one of the ZIKV-EDIII fragments, E298409, could induce potent neutralizing antibodies, which protected newborn mice and type I interferon receptor deficient adult A129 mice from lethal challenge with divergent ZIKV strains. The present study demonstrates that the identified EDIII fragment can be further developed as an effective and safe vaccine for prevention of ZIKV infection and that the anti-E298409 antibodies can be used for pre-exposure prophylaxis of ZIKV infection.